My name is Karen, and welcome back to Inquisitive Kids. Today, we are going to learn the rules of multiplying and dividing fractional expressions. In our last lesson, we had our introduction to fractional expressions, learning about its definition and its basic properties. That leads us to operations with fractional expressions. The basic properties that we learned from the last video will really help because it explains how the rules of multiplying and dividing fractional expressions work. So if you think you need more review on that, I will be linking its video in the description down below. As you can see, after this, we will be having 2 more videos focused on its addition and subtraction. Finally, we're going to move on to another new concept called rational functions. Learning goals. Master the rules of multiplication and division of fractional expressions. Perform multiplication and division of fractional expressions with polynomials as the numerator and denominator. Introduction. The volume of a rectangular container is V. The length of the base is A and the width is B. When the water in the container occupies m out of n of the volume, what would be the height of the water? The height of the container is V over AB, which means that the height of the water in the container would be V out of AB times m over n. Here's question 2. A large tractor plows A hectares in m days, and a small tractor plows A hectares in n days. How many times is the working efficiency of the large tractor greater than that of the small tractor? The working efficiency of the large tractor would be A out of m hectares a day, so A hectares per m days, and the working efficiency of the small tractor would be B out of n hectares a day, or B hectares per n days. The large tractor's efficiency would be A over m divided by B over n times the working efficiency of the small tractor. We are trying to find how much bigger is this number than this number we are dividing. So that explains the operation being used here. Multiplying and dividing fractional expressions. Fill in the following blanks using fractions. Well, I'm sure this is not that hard for you to solve. The first one would be 2 times 4 over 3 times 5, which is 8 out of 15. And the second one would be 2/3 times 5/4. Basic stuff. So think, what would this expression equal? And what about this division one? Compared with the multiplication and division rules of fractions, can you tell the multiplication and division rules of fractional expressions? So we have already learned all about fractions. What do you think the rules of multiplying and dividing fractional expressions would be? Well, actually, they're not that different. Multiplication of fractional expressions. When 2 fractional expressions are being multiplied, the product of the numerators is taken as the numerator of the product, and the product of the denominators is taken as the denominator of the product. So you multiply the numerators and you multiply the denominators. This is a good time to pause the video and take notes. What about if you're dividing? To divide 2 fractional expressions, you first need to reverse the position of the numerator and denominator of the divisor and then multiply with the dividend. If you had A over B times divided by C over D, here's how you would solve. I like to have 3 steps that I always keep in mind. Keep, switch, and flip. You keep the first fraction, you switch the operation into multiply, and you switch the second fraction into its reciprocal. You flip it around, which is D over C. So this would equal A over B times D over C, just the same way as you would solve the division of fractions. So Expressed mathematically, these two rules would look like this and this. Example 1. Calculate these two fractional expressions. Calculate the product or quotient of these two fractional expressions. Use the rules of multiplication and division of fractional expressions to help you solve. Okay, so here would be your solution. For the first one, you multiply the numerators, which would give you 4xy squared, and you multiply the denominators, which would be 6x cubed y. After, you still need to simplify. It would give you 2y over 3x squared. If in this position you think it's a bit complicated to simplify, you can always do it earlier. Say here at this step where you can cross simplify. Now for the next one. Division, remember, keep, switch, flip. So you have to switch this operation and turn the second fraction into its reciprocal. Now you can multiply, and after simplification you'll have negative 2bd over 5ac. Remember to reduce the fraction. That's a huge part in the multiplication and division of fractional expressions, especially if you are getting more advanced and you have more and more numbers. You have bigger and bigger numbers, more complex numbers. You want to be able to handle it all, so it's best to reduce. Carrying out fractional multiplication and division according to the rules. If the result is not in simplest form, it must be reduced to make the operation a result into simplest form. And here, we're turning division into multiplication. So, whenever you see a fractional expression division problem, just like you would with a fraction division problem, you always want to turn it into multiplication. Remember using keep, switch, and flip. Practice. Again, try to simplify these two expressions. For the first one, you would have 2x squared y cubed over 12x to the fourth power y, simplified y squared over 6x squared. Now for the next one, you would have 3x squared y squared over 12y cubed, simplified x squared over 4y. For the first one, you would multiply the numerators and multiply the denominators. For the second one, since there is a division sign, you want to keep, switch, and flip. Switch the operation while flipping around the second fraction to turn it into its reciprocal. Method summary. The numerator and denominator are both monomial fraction multiplication. So, you can directly operate according to numerator multiplied by numerator and denominator multiplied by denominator. The operation steps are you have to focus on the signs if it's positive or negative, and the rules of multiplication of fractional expressions. And here this is monomial, so you can directly multiply the two numerators and denominators. But what if it's a polynomial? What would you do in that case? Example 2. Calculate the product of these two fractional expressions. And I'll give you a hint. Think about what we learned in the last chapter with factoring polynomials. Now go ahead and solve. First, we need to factor the numerators and denominators. Yes, these are not monomials anymore. These are polynomials. So we have to turn it into the form of multiple expressions being multiplied together. So in factored form, we want to convert it into factored form. Original equation would equal a minus 2 squared over a minus 1 squared. Both the numerator and denominator of the first fraction are using the perfect square formula. Now this is something that you should have mastered a couple of lessons ago, but this is your last chance to go back and revise and really master this skill. So I will also be linking this video in the description down below. Also, I will be linking in this square difference formula. That's what we're using in this next fraction here. On the denominator, we are turning it into a plus 2 times a minus 2. So after multiplying the numerators and the denominators, we can reduce the fraction into a minus 2 over a minus 1 times a plus 2. Now, let's look at this second division question. Again, first factor the polynomials and then reduce. The first step would be to turn it into a multiplication problem, division into multiplication. And then, after removing the common factors from the second fraction and using the reverse square difference formula in the first fraction, this is what you will have. In arithmetic, integers can be regarded as fractions with a denominator of 1. So if you have a whole number, you can think of it as a fraction, but with a denominator of 1. Now, after multiplying, this is what you will have. And then, after simplifying, you have negative m over 7 plus m. Let's do some more practice. Simplify this expression. Here's the solution. First, you would use the square difference formulas. Multiply them together, and then simplify. You'll have x minus 3 over x plus 2. In this next, the original equation would become a squared plus 2a over a squared minus 6a plus 9 times, we're turning division into multiplication, a squared minus 3a over a squared minus 4. And now using our formulas, we can use the square difference formula or use the perfect square formula, or we can factor by removing common factors. Multiply and then simplify. We have a squared over a minus 3 times a minus 2. Key point summary. Here are the steps of conducting multiplication and division with fractional expressions. When the numerator and denominator of a fractional expression are in the form of the product of several factors, otherwise known as factored form, the common factors of the numerator and denominator can be reduced first. When the numerator and/or denominator is a polynomial, we first need to arrange the polynomials containing the same variable in their original fraction according to descending power or ascending power in an orderly fashion. When a whole number is encountered in the process of multiplication and division, it can be regarded as a denominator of 1. You can always turn a whole number into a fraction by giving it a denominator of 1. Factor the polynomials in the numerator or denominator of each fraction before multiplication or division. Now we're going to look at the powers of fractional expressions, and I don't mean that by what fractional expressions can do, I mean that by exponents and indexes. Compute according to the meaning of exponents. So these are all working with known numbers, given fractions. So use what you've learned in the past to solve these three problems. This first one is the same as 4 threes being multiplied together, which is 81. The next one is 2/3 times 2/3, 4/9. And finally, 2/3 times 2/3 times 2/3 times 2/3, multiplied 4 times in a row, which would be 16 over 81. Analogous to the operation of multiplying fractions, can you calculate the following expressions? So using the laws of exponents with fractions, how can you use them to solve fractional expressions? Well, this first one would be a over b times a over b, and after multiplying the numerators and the denominators, you'll have a squared over b squared. This next one, same thing, you'll have a cubed over b cubed. And the final one, you will have a raised to the 10th power over b raised to the 10th power. So this is actually really strange. I don't know why it wrote a g instead of a multiplication sign, but all you need to know is that it's supposed to be lots of multiplication signs in the middle, showing that there's many a over b's being multiplied together and that there is 10 of them. So if you see a g in this position anywhere further on this slide, just know that it means multiplication or division. Think about how you can fill in this blank right here. Usually when n is an integer, so positive and whole, this expression would equal a to the nth power over b to the nth power. When taking the power of a fractional expression, we take the power of the numerator and denominator separately. Think, so far, what are the arithmetic rules for exponentation of whole expressions? Well, here are the laws of exponents for whole expressions. So similarly, those also apply to fractional expressions. Here is the exponentation of fractional expressions. When multiplying a fractional expression, be sure to multiply the numerator and denominator separately. It should look like this instead of this. So a big no-no to writing it like this. The denominator and numerator both get an exponent. When giving fractional expressions exponents, you must first determine the sign of the result of the exponentation. The even power of a negative number is always going to be positive, and the odd power of a negative number is always going to be negative. So if you start with a negative fractional expression and the exponent that it has is positive, you will always end up with a positive result. But if it's a negative number that you're given an exponent to and the exponent is odd, then you're going to have a negative result. So this is no different with fractions. The same thing applies to fractional expressions. And number 3, when conducting mixed operations, do the exponents first and then do multiplication and division next. So sort of like PEMDAS or the order of operations. You always do exponents before you do multiplication and division. Let's do some practice together. Here's a word problem. A boat goes back and forth between 2 points A and B, which are 100 kilometers apart on the waterway. It is known that the speed of the water flow is 2 kilometers per hour and the speed of the boat in still water is x kilometers per hour. X is greater than 2. During the process, the ratio of the time spent sailing downstream to the time spent sailing upstream would be blank. Well, here is the analysis. The downstream speed is x plus 2 kilometers per hour and the upstream speed is x minus 2 kilometers per hour. So, from the question, we know that 100 over x plus 2 divided by 100 over x minus 2 is equal to x minus 2 over x plus 2. So our answer would be x minus 2 over x plus 2. Class summary. Multiplying and dividing fractional expressions. Here is what we learned about multiplication and division. Division is converted into multiplication first, and then the operation is performed according to the multiplication rule. And notice, first, that the numerator and denominator are monomials, firstly according to the rules, and then reduce to simplest fraction or integer. So if the numerator and denominator are monomials, then all you have to do is just multiply. But if the numerator and denominator are polynomials, you must convert it into factored form first. Master the rules of multiplication and division of fractional expressions. Perform multiplication and division of fractional expressions with polynomials as the numerator and denominator. Again, the links to the past videos that you can review on is still in the description down below, so you can go check that out and review some information before moving on to the next lesson of this series. And if you would like to be notified when we upload our next video, then be sure to hit that notification bell as well as the subscribe button so you won't miss out. Thank you so much for watching through Inquisitive Kids, and I'll see you next time.